Hey everyone, and welcome to The Explainer. So when you hear the word calcium, I'm willing to bet the very first thing that pops into your head is a tall glass of cold milk and the phrase strong bones, right? But today, we're going to completely shatter that simplistic view. We're looking at the surprising, literally universal power of calcium, unlocking what we're calling the calcium code.
Okay, let's jump right into our biological roadmap for today. We'll be covering 1. Beyond just strong bones, 2. The body's calcium regulators, 3. Diet, dosage, and health, 4. When calcium goes wrong, and finally, 5. Calcium in the wild.
All right, Section 1, Beyond Just Strong Bones, the microscopic messenger. So what is calcium actually for? I know, it sounds like a really basic question. As I mentioned, most of us just assume its primary job is to be the structural scaffolding for our skeleton. But what if I told you that our skeleton is mostly just a massive biological storage facility? The true magic of calcium doesn't happen when it's just sitting still inside a bone. It happens when it's released and actively moving through our cells. It is an incredibly dynamic biological tool.
Inside your body, calcium ions act as what we call second messengers. Think of them as the ultimate electrical switch. When a signal arrives at a cell, calcium basically rushes in to trigger critical cellular events. Actually, if you're listening to me right now and processing my words, you are actively using calcium. It's the exact trigger that allows neurotransmitters to be released from your neurons, firing signals all across your brain. And every single time a muscle in your body physically contracts, from your beating heart to the tiny muscles moving your eyes, that contraction is initiated by calcium. It's literally the spark of life itself.
Moving on to Section 2, the body's calcium regulators managing the vault.
You know, our bodies harbors this really stark biological contrast. Roughly 99% of our total calcium is locked away in bone mineral. It's this massive skeletal vault where it's largely unavailable for active work. Meanwhile, the active calcium pool floating inside a typical cell is tightly regulated at roughly 100 nanomolar. To put that into perspective, the body keeps intracellular calcium about 12,000 times lower than the fluids outside the cell. So we have this giant locked-away skeletal vault on one hand and this tiny, hyper-regulated active pool on the other that's actually keeping us alive second by second.
Well, how do we move calcium from that vault into the active pool? It all comes down to a two-step physiological feedback loop. Step 1. When your active calcium levels take a dip, your parathyroid gland secretes parathyroid hormone. This hormone essentially runs over to the bone vault and makes a withdrawal, pulling calcium from the bone directly into your bloodstream. Step 2. Calcitonin, which is secreted by the thyroid gland, steps in to oppose this action, basically making a metabolic deposit to lower those active blood calcium levels back down. It's a brilliant system, and it shows exactly how human plasma calcium remains one of the most closely guarded physiological variables in our entire body.
Let's get into Section 3, Diet, Dosage, and Health, Fueling the System.
Based on the daily recommendations from the U.S. Institute of Medicine, it's pretty interesting to see how our requirements shift as we age. Toddlers need about 700 milligrams a day, while adults generally need around 1,000 milligrams. But check this out. Our highest biological requirement actually peaks during the teen years at 1,300 milligrams a day. Why? Because this is a period of massive, rapid skeletal growth. The body is just frantically packing away as much calcium into the vault as possible for future use.
But where exactly should we be getting all this calcium? We always hear about drinking milk and eating spinach, right? Well, consider this. Per 100 grams, non-fat cow milk gives you 122 milligrams, and spinach gives you 99 milligrams. But Parmesan cheese, a 100-gram serving of Parmesan absolutely blows the others out of the water, packing a massive 1,140 milligrams of calcium. Now, okay, I definitely wouldn't recommend eating a giant block of Parmesan cheese every single day, but it is a really fun, fascinating look at how concentrated this mineral can be in certain foods.
Because calcium is so crucial, dietary supplements are incredibly popular. But we have to decode what grocery store labels are actually legally allowed to tell you. According to the FDA, it is scientifically sound to claim that adequate calcium, specifically at least 260 milligrams per serving, can help reduce the risk of osteoporosis. That's a given. However, if you see claims suggesting that calcium supplements can reduce the risk of hypertension or colon cancer, well, just know that the FDA has officially reviewed the science on that, and they found the evidence for those specific claims to be pretty inconsistent and inconclusive. Best to stick to the science of the vault for now. Which brings us to Section 4. When calcium goes wrong, the edge of imbalance. So let's look at the two extremes of imbalance, because the margin for error here is razor thin. On one side, we have hypocalcemia, which is abnormally low active calcium. Remember earlier how we said calcium is the switch for our nervous system? Well, without enough of it, the system gets incredibly erratic. It leads to a condition called tetany, marked by spontaneous, uncontrolled motor neuron discharge. Basically, your muscles just start firing on their own. On the flip side, we have hypercalcemia, way too much active calcium. Chronically elevated plasma calcium disrupts the delicate electrical signals in the heart, leading to very dangerous cardiac arrhythmias. This brilliantly illustrates exactly why our biology regulates this one specific element so fiercely.
Finally, Section 5, Calcium in the Wild, the biosphere's building block.
Because calcium isn't just a human necessity, folks, it is literally the biosphere's building block. Just look at plants. When they need to prevent water loss, calcium is the exact signal that triggers their pores, their stomata, to close up tight. Plants also absolutely need it to form cell walls and divide their cells. And if you look at the oceans, it's everywhere. Marine invertebrates rely heavily on calcium to build their tough outer exoskeletons. I mean, think of every single seashell you have ever picked up on a beach. Even these tiny microscopic marine algae called coccolithophores use calcium to form intricate protective plates around themselves. It is a completely universal tool. Which brings us to our final thought for today's explainer. If a single element can fire a human neuron, build a rigid seashell, and close a tiny plant's pores to save water, what other universal biological threads connect all life on Earth? It leaves you with a really profound sense of wonder, doesn't it? Our shared chemical architecture is absolutely stunning. Thank you so much for joining me on this deep dive into the true power of calcium. Keep learning, keep questioning, and I'll catch you in the next explainer.